In an object-oriented programming language, you will have multiple classes, multiple objects, and they can all relate to one another. In other words, one object can interact with another object from different classes. When one object interacts with another object, we call that an association. And these classes can be unrelated classes, but one object can exist without the other object existing. In other words, if you thought of a body has a body's not going to exist without the head's not going to exist without the body. There is a relationship there, but in that case, it's going to be a special type of a relationship. And we're going to learn what that is in just a little bit. But if we had a professor and we had a student, the professor could actually exist without the student object, and the student object could exist without the professor object. If the professor object retired, the student object still exists. If the student object graduates, leaves the institution, the professor object still exists. They're associated with each other, but they're unrelated, meaning one can exist without the other. A special form of a relationship is called aggregation, and it's often referred to as a has-a relationship. Sometimes they call it a weak relationship, a whole part relationship, because each object can have its own lifetime and exist independently, but there's no ownership involved. One object doesn't own the other object as a parent, or as if the one object is destroyed, then the other object has to be destroyed too. The one object can actually own another object as an attribute, but the owner object can exist without the child object, and the child object can exist without the owner object. Now, this might seem a little bit strange, but let's look at some examples. For instance, what the book says is you could have a faculty object, like a professor object, and that object could belong to a department. And if for some reason the department is ever deleted, it doesn't mean that the professor object is gone also. A car could have a radio, but that doesn't mean a car has to have a radio. It'd be sort of strange nowadays, but the car doesn't have to have the radio in order to exist. A car has a radio, but once again, if the radio's not there, the car's fine. A passenger has a car, but a car might not have a passenger. It's usually a one-directional association, meaning one object has another object, and only one class is really dependent upon that other class. For instance, let's look at the relationship we used in the book, and let's type in a program to represent that. Go ahead and click File, New File, and let's go ahead and save that file. And in my case, you're in the video, but I didn't actually create a folder to the workspace, and I could just click on it and do that, but I want you to get in the habit of actually working with folders and workspaces. So let's do a File, Add Folder to Workspace, and then I want you to go choose the path where you're storing all your files. Once you find that path, click Add. Now we have the folder there. Now if I did a File, Save As, we're going to see that we're in that folder. Now go ahead and call this whatever you want. I'm going to call it aggregate.py. Aggregate.py. Call it anything you want. Okay, now we have a Python source code file, and of course the smart thing to do would be to go add some comments like your name and a description of what's going on. But in aggregation, what we're going to do is we're going to have an example of multiple classes. We're going to have two classes there. And the two classes can work together. One class can have an object of another class, but both objects will live and exist without having that relationship too. It's a weak relationship, meaning they don't have to be tied together that when one object is destroyed, the other object is automatically destroyed too. They can exist without each other. That's why they call it a weak, but they still say it's a has-a relationship. One object has a relationship with another object. One object has an attribute that is another object from another class. So let's go ahead and set this up. We'll go ahead and create a variable or a class called baseball team. And this could be a volleyball team, a softball team, golf team, whatever. And let's go ahead and do a constructor, which we know is a def underscore underscore init and underscore underscore with the self. That's our constructor. That's a default constructor. And then let's go ahead and give it some attributes. We'll go ahead and say self, because remember, if you don't say self and you just put a word in there, that's a local variable, meaning it's only going to be visible in that method, but it's not an attribute for the object. Self team name is equal to name, and we're going to go ahead and pass name as a parameter. In fact, let's pass wins and losses as parameters. Self dot wins is equal to wins, and self dot losses is equal to losses. So this constructor for the baseball team says if you ever create an object of type baseball team, you're going to need to pass it 3 parameters. Remember, self is always a parameter in all your constructors, all of your methods. So 3 parameters come into it, and then we're going to take those values. These aren't attributes. These are just local variables, just like a function. These variables exist for the life of this method, just like a function would. Once that method is over, these variables cease to exist. Now, I didn't have to name them the same name as the attributes. In fact, if you notice, that's not the same name as this attribute. That's okay. They don't have to be. What happens is it takes the first value that you pass this constructor and it assigns it to this parameter. The second value is assigned to that parameter, and the third value is assigned to that parameter. And that happens when you go and instantiate or construct the variable. In fact, I'll just show you, don't type this in yet. I could just say O team equals baseball team parenthesis, and we'll say Rockies 10, comma 2, right? Very hopeful. And so this value would go into name, this value would go into wins, and this value goes into losses. Now, if I had changed the order of that and did this, then the 10 goes into name, the 2 goes into wins, and the Rockies goes into the word losses. So make sure that whatever you're passing is in the right order as to what the constructor or the method is receiving. Go ahead and delete that statement. We'll get to that later. So here's our constructor. Let's go ahead and write a method. And the way you write a method is you just say the word def and you give it the method name. We're going to call this method get win loss percent. So this will be how many times do they really win percentage wise. And then remember, every method has to receive the self parameter. And in this case, you could assign values, you could do calculations, and what we're going to do is we're going to actually do a calculation. And let's give it a variable. We'll say f% is equal to, and we'll say self dot wins divided by the total number of games, which is the self dot wins plus self dot losses. That gives us a percentage. But what we want to do with that percentage is we want that percentage to be a number rather than just a decimal number. Like instead of a 0.500, we want it to be 50%. And so we'll say that whole value, notice the parentheses, this parenthesis goes with this parenthesis, and this parenthesis goes with that parenthesis. Let's multiply that by 100. And that way, if the value was like 0.529, we would really turn it into 52.9 because we're going to multiply that by 100. That's why we're doing that. Okay, now that I have that value, let's say whoever calls this method wants to receive that value back. So let's go ahead and return it, but I want to round it. So I'm going to go ahead and round f%, and I only want to return 1 decimal place with it. So that will now return, if the number was 0.529, we turned it into 52.9. In fact, if by chance it was a larger number like that, we would return with the round that value. So we rounded up to 1 position to the right of the decimal. That's what the round with the comma 1 does. So if anybody calls this method, we're going to return that value. Let's go create another class now. Watch your indenting. So we pull it back all the way to the left. So it's a brand new class called player. And in the player class, let's go ahead and create another constructor. And in that constructor, we actually want to receive some parameters. Of course, you receive self. By the way, you don't have to put these spaces here. I like to sort of break it up for readability. But we're going to receive a player name, and we're going to receive what team they actually might be on. And then we're going to say self.player name is equal to the player name parameter. Remember, this is not an attribute. This is a parameter. Those are not the same. And that's why I use the keyword self there. That distinguishes between a parameter and an attribute. And then let's go ahead and say self.team is equal to the team parameter, whatever that's going to be. And then let's write another method. And this method is going to be called getInfo. And it receives self. And this is going to actually return information about the player. And so we're going to go ahead and do a return statement. And I had this other already prepared to type in. We're going to return the player name concatenated with, plays on the, concatenated with, whatever team is, which is going to be a team object. Now, that team object is really going to end up being like a baseball team. And that baseball team has an attribute called team name. So we're saying if this player object is assigned to a team object, then let's go return the team name for the team object for the player object. Let me say that again. Let's go return the team name attribute for the baseball team assigned to the team or to the player object. So the team attribute, team object for the player object, concatenated with who wins, and then we'll say, let's go ahead and take the team object, call the win-loss percent, which returns the percentage of how often they win, rounded to 1. We convert it to a string, and you have to do that because we're concatenating with strings. And then we just concatenated a percent symbol with of the time. That's what the player method will do. Did you notice that in this case, we're saying a player has a team. So the player has a team object, and during construction, we're going to receive that team object and make that link. Can the player exist without the team? Yeah, we could pass a null to it. Would the method work? No, but the object would be created. Can the team object exist without the player? Yeah, it can. So how does that actually work? Well, what we're going to do is let's go ahead and create a team object by calling the constructor. And remember, our constructor is looking for a team name. So we'll pass it the Rockies, and we'll pass it the number of wins, the number of losses. That creates a baseball team object. So this team object now has a team name, wins, losses, and access to that method. Let's create another object, the player object. And for that player object, we're going to call the player constructor. We're going to pass the name Nolan Arenado. And we are also going to pass the team object we just created. There's the team object. So that name, Nolan Arenado goes into player name, and OTeam goes into that parameter, and now a player has a team. A team doesn't have a player, but a player has a team. Now what we could do is we could print that player object dot get info method. And so when we ran this, it would go ahead and call this method display the information. But what I want to point out is you could also print oteam.teamName. Why? Because the team object is completely separate from the player object. Once the player object is done, we don't use it anymore. this team object still lives. And so that's why a player has a team, but the team doesn't has a player. And this is an example of aggregation. It's a weak relationship because one object could still live if the other object doesn't exist. Let's go ahead and run this. We'll save it and run it. And currently, let me go ahead and show you something. Default shell, we've been running in the command shell, I think. So let's go ahead and run in the command shell, which looks more like this. And you can say Python aggregate.py. There's the object that was created, the player object, has a team object, calls the method, and when we're done, we can still work with the team object. Now, while I'm here, let me go ahead and show you something that you might not have seen yet. Currently, we're working in a command window. We could have, by clicking on this drop-down list, we could have done a select default shell, and we could have done a PowerShell. Close, open window again. Now we're working in PowerShell, Windows PowerShell versus command. The command shell is like the old school command window. PowerShell is like the new and improved command window. But one thing I want you to start getting used to, because we're going to move into Git and GitHub in the next chapter, is I want you to start learning how to use the Git bash shell. Here's how you do that. You go to PowerShell, set default shell, and you could choose Git bash. Close that shell, open it back up. Here's the new shell. Notice it's different. Colorization is there, a $sign. That's because this is emulating a Linux environment, a Linux or a Mac OS environment. And I could still type Python aggregate.py and it still runs. It's just a different way of interacting with a command window or the operating system. Let's go ahead and set it back to the command window, and in chapter 13 we'll actually make this shift permanent. So I click the down arrow, choose command prompt, close the terminal, run terminal, and now we're back to the command prompt. And you could run that program one more time, Python aggregate.py. The program still works. So this is an example of aggregation because you have more than one class, more than one object, and one class has a reference to another object. But the other object can still exist and be functional without actually worrying about the related or aggregated object. OTeam is still functional and works. It doesn't need the player object. Player object needs team object, but it's not the other way around, and that's why it's weak, because they both don't rely upon each other. That's aggregation.